All right, let's tackle a classic brain teaser today. It's a famous problem from the Irodov collection that looks super complicated at first glance, but trust me, there's an incredibly simple and elegant solution hiding inside. You ready to dive in?
So here's how we're going to break this down. First, we'll get our heads around the riddle itself. Then, and this is the fun part, we'll look at it from two totally different viewpoints. After that, we'll walk through the solution, which is just beautiful, and finally, we'll talk about the big secret weapon that physicists use, which this problem teaches us perfectly.
Okay, let's get into it. Section 1, the river riddle. First things first, we can't solve anything until we know exactly what we're up against, right? So let's look at the problem, word for word. So there you have it. You've got a motorboat, it passes a little raft, it keeps going downstream for exactly an hour, then it flips a U-turn. Sometime later, it passes the raft again, and by that time, the raft has floated 6 kilometers from where they first met. The big question is, how fast is that river flowing? Okay, let's pull out the important bits. We've got our givens, 60 minutes and 6 kilometers. And we have one really important clue. The boat's engine power is constant. What that means is its speed through the water stays the same. The only thing we need to figure out is the river's speed.
So, what's your first instinct here? I'm guessing it's the same as mine was. You'd picture yourself standing on the riverbank, right? Watching the boat go down, turn around, come back. It seems like the most logical way to do it, but oh boy, does it get complicated fast.
I mean, just look at this. From the shore, you've got to juggle all these different variables. You've got the boat's speed, the river's speed, then you've got their combined speed when it's going downstream, and the boat's speed minus the river's speed when it's fighting the current to come back upstream. And the times for each part of the trip are different too. You can totally solve it this way with a bunch of algebra, but it's just a mess.
And this is where we need to pause. Because whenever a physics problem looks this messy, it's usually a huge hint that we're looking at it all wrong. There's almost always a smarter, more elegant way. So, is there a better angle? You bet there is.
And here it is. This is the big aha moment. The key to cracking this thing isn't about doing more complicated math. It's about a simple, powerful shift in how we look at it. So what if we stop standing on the shore and instead we jump into the river? Imagine we're floating right there in the water, moving with the current.
This idea has a name, and it's a cornerstone of physics. It's called changing your frame of reference, and it's one of the most powerful tricks in the book. All it really means is picking a point of view, a perspective, that makes everything you're looking at as simple as it can possibly be. And you can see the difference right here. From the shore, it's chaos, right? The water's moving, the raft's moving, the boat's moving. But the second we jump into the river's frame of reference, let's say we're floating right next to that raft, suddenly the water around us isn't moving at all. It's still. The raft, it's stationary. The only thing moving from our new perspective is the boat. Okay, so now that we've made that mental jump, all that ugly algebra just evaporates. It's gone. And what's left is a super elegant solution. This is really the beautiful part of this whole puzzle.
Okay, think about it from the raft's point of view. From where it's sitting, the water is perfectly still. So, the boat travels away from the raft for 60 minutes. Now remember that key clue? The engine duty is constant. That means the boat's speed relative to the water is the same going away as it is coming back. Well, if it takes 60 minutes to go away at a certain speed, how long is it going to take to come back at that exact same speed? Yep, 60 minutes. It's just perfect symmetry.
So let's add that up. The boat travels away for 60 minutes, and it travels back for 60 minutes. The total time that passed from the first meeting to the second was 120 minutes, or, 2 hours.
All right, now that we know the total time, we can mentally step back onto the shore. We know the whole thing, from start to finish, took 2 hours. And what happened in those 2 hours? Well, the problem told us. The river carried that raft exactly 6 kilometers downstream. The raft is basically just a perfect little speedometer for the river current. And just like that, the final calculation is, well, it's almost too easy. The river speed is just the distance the raft moved divided by the total time it took. So 6 kilometers divided by 2 hours, and there's our answer, 3 kilometers per hour. That's it. We're done. No crazy equations, just a simple change in how we looked at the problem.
You know, this puzzle is so much more than just a boat on a river. It's like a perfect little lesson in how physicists think. It's all about looking at a situation that seems really complex and finding the hidden simplicity inside.
So what's the big idea we should all take away from this? It's that your most powerful problem-solving tool isn't always some fancy formula. It's your perspective.
Finding the right way to look at something, the right frame of reference, can turn a problem that feels impossible into something that's, well, almost obvious.
And that brings me to a final question for you. Because this idea, it doesn't just work in physics, right? It works everywhere. So think about it for a second. What's one complex problem in your life right now, at work, at home, anywhere, that might just solve itself if you could find a way to look at it from a completely new angle?